times. Okay, so when it comes to trig, okay, make sure you know all your formulae. So the ones that I'm talking about are the ones that are not supplied on your formula sheet, like all your reduction formulae, what happens with negative angles, etc., etc. The only way you can do well in trig is to study. You have to go and make sure that you've learned all the rules. Otherwise, you're not going to be able to do anything. Also, make sure you know your co-ratios. So here, when I'm talking about things that you need to know here, we're talking about, let's just write this down for you guys. So reduction formulae, your co-ratios. You know what I mean when I say your co-ratios. So in other words, if you have got the sine of 90 plus theta, for example, okay, so you need to learn that that's equal to cos theta, etc., etc. Negative angles. Okay, so for example, if you've got cos minus theta, you need to learn that it reduces to positive cos theta, stuff like that. Okay, and then obviously the formulae that are going to be given to you, I've got them down below, but those would be your compound angles and your double angles. And then obviously when it comes to 2D trig and 3D trig, they will also supply you with the cosine rule, the sine rule, and the area rule. Okay, check your calculators in degrees. That's really important. If your calculator is set on radians, then you will get completely different answers for everything. Okay, so that's something that you need to make sure you do as well. Maybe before you start your paper 2 exam, just reset your calculator entirely. If you want to know how to do that with a Casio, I don't know how to do it with a Sharp. I think with a Sharp, there's just like a button you press. But with a Casio, if you want to know how to reset your Casio calculator, I can tell you how to do that as well. Use your answer book to plan your exam. So for example, do the trig first. So if we're talking specifically about paper 2, what I would do, I think if I was you guys, is I would get started on the stats, and I would do the stats questions first because those are the easiest. Then I would go and do trig. Then I would do analytical geometry, and I would leave the Euclidean for last, but it's up to you. Okay, very important, don't make up new rules. So we see that all the time in maths where, you know, 2 different rules get put together in a strange way, or yeah, people make stuff up that isn't actually true. So yeah, don't make up new rules. Show all your steps so that you can get all the marks. Use correct algebraic steps. So that means, like in terms of factorizing, make sure that you factorize correctly. Make sure that if, you know, you're working with identities and you need to find, you're adding 2 fractions, that you find the lowest common denominator in the correct way. Make sure that when you are adding and subtracting, that you only add and subtract like terms, that kind of stuff. Okay, so all the grade 11 as well as grade 12 trig. So that means you need to have an understanding and an expectation of the kinds of questions that are going to come up. Okay, so if I just quiz you guys very quickly before we get started, what sort of questions would you expect to see in the trig section? Questions on what? What are you expecting to see? Okay, so when you say proving Canicilla, do you mean proving left-hand side equals right-hand side? Identities, okay, cool. So Boutlé and Canicilla have both said you would be asked to prove an identity. Definitely, you will, 100%. So that's one thing you would get. What else are you expecting to see? General formula, so you mean general solution? Absolutely, Maite. So you're expecting to see a general solution? Absolutely, that will definitely come up. Theorem proving, I'm not following you, Tisha. Theorem proving AA. I don't understand exactly what that means. Maybe you can just elaborate on that a little bit for me. The cast diagram, absolutely, can you see this? So we would expect to see a question involving Pythagoras and the cast diagram. So we'll be working somewhere on the Cartesian plane. We would expect questions like that. If they didn't give us a question on the Cartesian plane, yep, absolutely, trig functions. Trig functions, absolutely. So a trig functions question, not under the general trig, but yes, Trig functions, we would expect a question on that as well, absolutely. Triangles, so 3D, 2D, 3D trig, which is the triangles. Yes, solution of triangles, good. Okay, so these two form their own question. Proving theorems. What theorems could they get you to prove trig? Okay, like theorem 1 to 7. Which theorems are you referring to, Tisha? Theorems 1 to 7. Euclidean, yes, but that would be under Euclidean geometry. Absolutely. Absolutely, they would get you to, but that would be under a separate section. We're just talking now about the trig questions. Okay, so some of the other things that you could expect to see in your general trig section, so would be a question on simplification using reduction formulae. So you can expect to see that. Another question that you can expect to see is a ratio in terms of a letter. Okay, so when it comes to trig, we have these general questions that they're always going to ask us, and then maybe they might throw in some kind of difficult problem solving question that we've never seen before, that we now need to go and apply what we know to try and figure it out. So we must learn to expect all these sorts of questions in the trig section. So if we go and have a look at these questions that are coming, we'll come back to our formulae now. Let's just go down here. There we go. So question 5.1. All right, when it says without using a calculator, then they do mean without using a calculator. All right, you're not allowed to, if they can see that you use a calculator, you are going to be penalized for that. So then here we go, you're proving of your identity. So here's a simplification, proving of an identity. Here in 5.3, what do we call that? It's one of the ones we listed. What's this one called in 5.3? Anybody know?
Ma'am, is it simplifying?
No, it's not. This is simplifying over here in 5.1 using our reduction formulae. But 5.3, Cassandra, is actually a question about ratio in terms of a letter. Okay, matrix, this is ratio in terms of a letter. So in this case, the letter that they're working with is the letter P. Okay, all right, so ratio in terms of a letter is this question 5.3. Then over here, this is something else that they've asked us to do. They've asked us to prove something. So this is one of the formulae they could ask you to prove, Tisha. Maybe this is what you were talking about. Question 6.1.2 is another simplification question, and in 6.2 there's our general solution. Okay, so we can see these sorts of questions that we are expecting they're going to come up. They haven't asked us anything on the Cartesian plane, which is why I decided that I would start with one of those sorts of questions. All right, so just running through it again, you have got your compound angles. All right, so your compound angle, your sine compound angles. These one over here, remember sine keeps its sign. So if it's plus here, it's plus there. And if it's minus here, it's minus over there. Cosine does not keep its sign. Okay, so your cosine rules are a little bit different. Okay, your double angles, you have your sine double angle, which you can only write sine 2 theta as 2 sine theta cos theta, and then we all remember with cos 2 theta or cos 2 alpha, there's 3 different ways in which we can write it. Okay, now most of the time, if we are working with questions like those that are Pythagoras or on the Cartesian plane, it generally doesn't matter which one of these 3 we use, but certainly when it comes to general solutions and identities, then it's going to matter, and that becomes a little bit more difficult to sort of try and work out. Okay, so let's jump straight into it. This question over here is one of these Pythagoras, cast, Cartesian plane sorts of questions. And I want to do this question with you, not really because of question A and question B, but more because of question C, but we'll talk about it when we get there. All right, so they have told us that sine 2a is root 5 over 3, and they've told us 2a is an angle between 90 and 270. Determine without the use of a calculator. So we know that we can't ignore that. And they've given us 3 things to calculate: cos 2a, tan 2a, and sine a. What is our first step matrix? What's the first thing that we're going to do when we encounter a question like this one? Anybody know? Draw, absolutely, absolutely. Okay, determine x and y and r, certainly. Okay, so both of you are correct. We want to draw a diagram. And then after we've drawn our diagram and we know what quadrant we're working in, we then want to work out what's missing. Okay, so either the x or the y or the r, and then we're going to use Pythagoras to determine what's missing. Okay, yeah, absolutely. We've got to, even if it says to us, even if it doesn't say that we need to draw a diagram, you are supposed to draw a diagram. And when you draw your diagram as well, matrix, you need to make sure, oh, that is a terrible y-axis. You need to make sure that you label things correctly as well. Okay, so what I'm going to do is I'm going to use their x and y axes because they're much better than the ones that I can draw. Okay, so there we go. We've got ourselves a set of x and y axes. And what do we notice when we look at sine 2a equals root 5 over 3? We can see that our ratio that they've given us is a positive ratio. So now we're using the cast diagram, and which 2 quadrants is sine positive? It's positive in quadrant 1 and 2, exactly. So either we're working in quadrant 1 or we're working in quadrant 2. But this second piece of information helps us to decide between which 2 quadrants we're working in. Okay, because we can't work in both. The terminal arm has to come to rest in one quadrant. So it's between 90 and 270. Sine 2a is positive, so therefore we must be working in quadrant what, guys? Perfect. Okay, so we're working in quadrant 2. All right, so now you're going to come along, you're going to draw your terminal arm. There's your angle 2A, you are supposed to label it. And now we need to fill in some information over here. Do we know what the x coordinate at the end of the terminal arm is? Do we know what the x coordinate at the end of the terminal arm is? Is that something that's been given to us? Correct, Boutle. No, we don't. No, we don't. What do we know? How are we interpreting sine 2a? What does it mean to us? There we go. All right, so they've given us y and they've given us r. Okay, so in this diagram, we do not yet know what x is. They've told us that y is equal to root 5, and they've told us that r is equal to 3. Okay. Yes, and we have the hypotenuse. We certainly do, Tisha. Okay, now you guys are going to work out the value of x using Pythagoras, and then we're going to move on. Okay, so you guys are going to work out the value of x using Pythagoras, and then we will go to the next step of the question. Okay. And as soon as you're done, you can pop a done into the chat. Okay, so Kanye Sile says that x is equal to 2. Let's see what the other answers are. Tisha's got 4. What did you get, Thelma? Whoopsie. Tisha says x is equal to 4. Michael got 2. Butle got 2. Aha. Cassandra. 2, 2, 2, 2, 2. Okay, guys.
Sorry, Lee. Michelle
Yes.
wants to know if he can use
sorry.
Sakatoa. Sakatoa.
No, we're not using Sokotoa in this particular situation. No. Okay, because we're not, no. We don't want to know what the size of the angle is. We're just trying to use Pythagoras. Okay, so no, not Sokotoa. Okay, now I think you guys have cottoned on after Cassandra put her answer in there. There we go. Okay, remember, yes. Okay, you are in quadrant 2. Okay, in quadrant 2, x is negative. This is the biggest mistake that matrics make, is with their signs. Okay, so I know all of you can do Pythagoras. Lovely, lovely, lovely. But remember, you are in quadrant 2 where x is negative. So absolutely, you should have had negative 2 as your answer. Okay, so be super, super, super careful with your signs. Now that you know what x and y are and r are, you can answer any question that you want. Okay, so cos 2a, how are we going to rewrite cos 2a? Does it matter? No, it doesn't matter. So we can just pick something. All right, I don't know about you guys, but I often just choose 2 cos squared a minus 1. I don't know why, I just do. So we've got 2. Then cos a is going to be negative 2 over 3, which we need to square, and then we've got to take 1 away from that. Okay, and then we can work out what the answer to that is going to end up being. You guys can tell me what it is, and we can move on to the next question. Okay, so here, tan 2a. All right, anyone got an answer for A yet? What did you get? Yes, can you see it? Absolutely, absolutely. So for cos 2a, you're going to be using one of these 3 here. So either you can use cos squared a minus sine squared a, or you can use 1 minus 2 sine squared a, or you can use 2 cos squared a minus 1. It won't matter. Actually, no, hang on a second. Sorry. We worked in terms of 2a, didn't we? Beg your pardon. Sorry, our angle was in terms of 2a. Sorry. No, you're quite right. Our angle was in terms of 2a. I beg your pardon. So cos 2a is simply x over r. Okay, so that would be minus 2 over 3. My apologies. It's that easy. All right, tan 2a is going to be y over x. So that's going to give us root 5 over negative 2. Agreed. And C, the last question. Sine A. Sorry, this is the one that I keep thinking about. And I'm rushing to get to, but anyway. So now sine A. What do you notice is different here to what they gave us? Which is what Canicelia just pointed out to me, and the whole purpose of us doing this question. Exactly, it's not a double angle. So here they want us to work in terms of sine A, But here we were working in terms of 2a. Our angle is 2a. Yeah, exactly. It's not a double angle. So how are we going to deal with this question? How are we going to work in terms of a and not 2a? Could we take the value of sine 2a and just divide it by 2? Would that work? What do you think?
Ma'am,
Yes.
I think that we can express our sine 2a into 2 sine a times cos a.
Just say that again. You think we can express?
We can express it in the form of 2 sine a times cos a.
Okay, but that would be sine 2a, wouldn't it?
Yes, ma'am.
Okay, so absolutely, if they gave us sine 2a, that's exactly what we would do with it. We would write it as 2 sine a cos a, but they haven't given us sine 2a. They've just given us sine a on its own. Okay, they've just given us this. All right, and this is where, and this is the hard part. Okay, these over here are so very, very important. Okay, because they are cos 2a is what allows you to write things in terms of sine a or cos a in this particular case. All right, now I'm going to show you now what I mean. All right, you guys know that cos 2a is equal to 1 minus 2 sine squared a, right? We know what cos 2a is equal to in this case because we did it in part A. It's equal to minus 2 over 3. So what we're going to do is we're going to make sine A the subject to the formula. I'm just moving these guys down. So in other words, I'm going to take this term over here now over to the left-hand side. That's going to give me 2 sine squared A is equal to 1 plus 2 over 3. I'm now going to make sine squared A the subject of the formula. So now I want to say 1 plus 2 over 3 equals, and then I want to divide it by 2. What are you guys getting? You're getting 5 over 6 as an answer? Okay, good job. And now if we want to work out what the square root is, we would now have to, or we want to work out what sine A is, we would have to square root both sides. So in this case over here, let's just pick the right color. Sine A would be equal to, and sine A would have to be an angle in the first quadrant, so sine A would be positive, not negative, so we are going to accept positive root 5 over 6 as our answer. I think what I might have done is left some of you behind here in terms of how we got to this answer. How does this feel? Does this make sense to you? Okay, Johannes, I just want to address something that that you've said, which is a common mistake that a lot of people make. All right, so a lot of people, and this is wrong. Okay, what I'm doing now is wrong, Matrix. Okay, that's why I'm talking to you about it. Okay, so let me just write here that this is wrong. Okay, a lot of people think that sine A can be determined by taking sine 2a and dividing it by 2. Okay, now that doesn't work. And the reason why it doesn't work is because remember, if we're talking about sine A, we are working along a sine curve. All right, so if we have a look here at our sine graph, Okay, you guys all remember what a sine graph looks like. Okay, so here would be 90 and there would be 100. Why does it do this? 180 and there would be 270 and here would be 360 and there would be 0 degrees. Okay, so now let's just think about this, guys. The sine of 30 is how much? 1/2, right? Okay. If I now take the sine of 60, can I say that the sine of 60 is 1/2 times 2? It's double it. So it's equal to 1. Is that true? No, I'm writing absolute nonsense, aren't I? Absolute nonsense. We know that the sine of 90 is equal to 1. Okay, so here the sine of 60 is actually √3/2. So can you see that when we halve the angle, we're not halving the ratio? Does that make sense to everybody? Right, so we cannot use this logic. Okay, it doesn't work. Right, so if we halve the ratio, we're not going to halve the angle as well. Okay, so that is completely wrong. We're working along a curve. It doesn't work. Okay, so the only way that you can solve for sine A, or if they wanted cos A, is for you to use cos 2A. All right, so you're going to write cos 2A in this case as 1 minus 2 sine squared A, because sine A is what we're solving for. Okay, and then we're going to make that the subject of the formula, sub in our values, and there we go. Okay, everybody happy with that? Making sense? Okay. All right, let's move on and let's talk about one of the other sorts of questions that we can get. Okay, so 5.1 is here because this is supposed to be something that everybody can do, right? So I'm going to let you guys do 5.1 and then we're going to talk about your answer and we're going to talk about where you're going to get your marks. So try 5.1, you're using reduction formulae. And as soon as you're done, just say so, and then we can go through it. And just, yeah, tell me what you've got as an answer. Anyone got an answer yet?
Yes, ma'am.
Cool. Cassandra, what did you get?
Ma'am, I got cos x.
Okay, so Cassandra got cos x. All right, Neo, what did you get? Cos x. And Yusile, what did you get? Cos x. Done. Butle, what did you get? And Sihle is done. Good job. Cos x as well. Okay. All right. Well, let's do this very quickly together, and hopefully that is correct. So when they say to one trigonometric ratio, that's exactly what we would want. So we would either want sine x, cos x, or tan x as our answer. That's what they're looking for. Okay, so sine 140, we're working with our reduction formulae. That's second quadrant, so this will reduce to sine 40. Sine 360 minus x, again, we're working with our cast diagram, so that's fourth quadrant, so this is going to reduce to negative sine x. All over cos 50. Cos 50 and sine 40 are exactly the same thing. They're co-ratios. So I could also write cos 50 as sine 40, and then I can divide something at the top or something at the bottom. And then underneath tan minus x, I would write as minus tan x. Now, the rule is when you reduce, you've got to write what you get as a result of reducing. So we can see that this is out of 6. So you're going to get a mark on this, you're going to get a mark on this. I don't think that they would give you a mark. Mind you, they probably could give you a mark on that, but they're definitely going to give you a mark on reducing that to negative tan x as well. Okay. When you say reduce after you've reduced, it depends, like how, can you see? Give me an example of what you've done, and then I can.
So ma'am, for sine 140 degrees, I reduced it to sine 40 degrees. And then I also did, oh, okay, ma'am, my question was wrong. My question was wrong.
That's okay.
Can I use co-ratios after reducing? Like
Yes.
I turned my sine 40 into a cos 50 degrees.
Perfect. Absolutely. Absolutely not a problem at all. So in other words, you just did yours a little bit differently to me. So over here, instead of writing, this stupid pen honestly drives me nuts. Okay, so over here, instead of you writing the sine 40, you then wrote that as cos 50, and then you had cos 50 down at the bottom. Absolutely, can you see there's nothing wrong with that? Okay, so anything divided by itself is 1. And then I don't know about you guys, but I like to get rid of the signs early on. So a negative divided by a negative is a positive. And then essentially what you've got here is sine x divided by tan x. Okay, and sine x divided by tan x means sine x over cos x. So we would definitely get another mark here for using our tan identity. And then we would keep that as sine x, tip and times. We're going to change this divide into a times, put cos x at the top and sine x at the bottom, and I quite agree with you guys. We would end up with cos x as our final answer. Okay, good job. Well done. Very nice. Okay, so you can see that's a cool way to get 6 marks. Everybody must be able to get those 6 marks. Let's barrel on now, proving the identity. Okay, so now we're proving, like you had said in the beginning, left-hand side equals right-hand side. It is not an equation, so you cannot move terms from one side to the other. Either you work with the left, or you work with the right, or you can work with both, but independently of one another. Okay, so there are sometimes questions where you have to work with the left and then work with the right separately, and then you arrive at the same answer for both and then conclude that left-hand side equals right-hand side. But you cannot move terms from one side to another. It's not an equation. Okay, so you will be penalized heavily if you do that. Okay, probably take all 4 marks away from you. Which side do you think we need to start with here, Matrix? Not much going on the right, is there? So we're going to start on the left, and we're going to write in, sorry, 5.2, let me just put that in. On the left-hand side, we have minus 2 sine squared x plus cos x plus 1 all over 1 minus cos 540 minus x. Okay, what do you guys notice about the numerator? Does anybody see anything that you think we could work with or change? Remember, we're always trying to rewrite things in a different way using, okay, I agree with you. We would have to definitely do something about the 540, definitely. What would we normally do in a situation like this? Can you see this? So if they've given us the 540, what would we do? Yes, Butle, where do you see the cos double angle? What's the cos double angle that you see?
In the numerator.
Absolutely.
Yes, ma'am.
No,
The
tell me
one.
what. Yes.
The 1 and the negative 2 sine x. You can put the 1
Beautiful.
yes, ma'am, in front and then minus there.
100%. That was so nice. I'm so glad that you saw that. Okay, so I don't know if the rest of you noticed what Butle noticed, but that was absolutely beautiful. Okay, so there she sees the cosine double angle formula. Okay, so what she's identified, what Butle has identified here for us, guys, is this guy over here. Okay, they've just separated it. All right, so they've written the minus 2 sine squared x or whatever it is at the front, and then they've moved the 1 to the back, which is quite sneaky of them, isn't it? But there it is. I agree with you. And then here we've got plus cos x. I'm going to ask you again, can you see what you think we should do to this 540? I'm just going to deal with this first of all. All right, so we've got 1 minus 2 sine squared x plus cos x, and we know that that is cos 2x. We'll deal with that in our next line. And now, Kanisila, I'm coming back to you and I'm asking you, what are we going to do about this? There we go. There we go, Tisha, nice. Subtract 360, not 180. Okay, not 180. You can't subtract 180 because then you're not quite right. Tisha, you are correct. Okay, you've got to subtract 360 so that you end up in the same quadrant. Okay, you've got to do full circle. So if you were in quadrant 2 and you subtract 360, you're going to stay in quadrant 2. Okay, so yes, very definitely subtracting 360. And what does that give us? 540 minus 360 would be 180, isn't it? So we'd have 180 minus x over here. Okay, now let's just move this down. Okay, bearing in mind on the right hand side we want 2 cos x minus 1. That's where we're headed. And I don't know if you remember the course that we did on trig earlier this year, but I spoke to you guys quite a lot about what do you see the cos 2x together with, and use what it's been put together with as a guide on how to write it. Can you see your hands up? Go for it. What did you want to ask?
Ma'am, for questions like that, the cos of 140 minus x, ma'am, would we always have to subtract 360, or are they sometimes we have to separate it with 180, or it's always 360 degrees?
No, it's always 360 degrees. I think maybe what you're getting confused with, Kanisile, is general solutions and tan, where we're working in multiples of 180, but we never ever subtract 180. If we're going to add or subtract anything, it's always going to be 360, so that we stay in the same quadrant. Does that make sense to you?
Yes, ma'am.
Okay. No problem. I'm so glad you asked. Now this is something that you know. All right. So when you see cos 2x and it's been put together with cos x. Normally what we would do is we would write cos 2x as 2 cos squared x minus 1 together with our cos x. If we see cos 2x and it's together with sine x in an expression, then the best way to write cos 2x is as 1 minus 2 sine squared x plus your sine x. So it's this term over here that tells us how to write that. Does that make sense to you? It's this term over here, if it was a plus, that tells us what to do with this one. All right, and if we had cos 2x together with sine x cos x, then probably the best way to write cos 2x would be as cos squared x minus sine squared x. Okay, just as a general rule of thumb. I'm just going to rub that out. I'll just give us a bit more space to write. Okay, so now going back up here, we are going to write 1 minus 2 sine squared x. I'm going to go straight to writing this because it's okay for me to do that. I'm going to go straight to writing it like this. 2 cos squared x plus cos x plus 1. Does that make sense to everybody? Matrix, does it make sense? Do you know what I've done? You sure? Thanks for the thumbs up, Boutle. Everybody else? If you're not sure, no, okay. No problem. That's why I thought, okay. If those of you that understood that want to carry on with the rest of the question, I'll catch you up. That's fine. You guys can go off. What I've done is this. Okay, so sorry, I'm just reading in the chat here. Okay, so Oratile and Michelle, I know you guys had a couple of questions around this. Okay, so your 1 minus 2 sine squared x, okay, is cos 2x, isn't it? And what I've done is I've written cos 2x as 2 cos squared x minus 1. But I am now including that with the cos x. So what I'm doing here is I'm rewriting 1 minus 2 sine squared x as 2 cos squared x plus 1. And then I've just brought this term down and I've stuck it in the middle. And the reason that I'm putting it in the middle is because then I've got a trinomial at the top. Does that make sense, Oratile, Michelle? All right, okay, good stuff. And then now here down at the bottom, I've got 1 minus, and then I've got to reduce. So this would give me negative cos x. Okay, you've got to write what you get as a result of reducing. Okay, up at the top now, this gives us a trinomial, which we can factorize into 2 brackets. So that gives us 2 cos x. And then over here, we've got cos x. Yes, Aisha, what's your question?
Ma'am, so I see that you took the cos x and put in the middle, but then since we took it from 2 cos squared x minus 1, isn't it supposed to be minus 1, not plus 1? I just don't understand how it's plus 1.
Oh, sorry, you're quite right. It is minus 1. Thank you. You're quite right, it is minus 1. Sorry, my mistake. Sorry, I don't know why I wrote plus 1. Sorry. Stopped concentrating. Thank you, Aisha. Okay, then at the bottom, oh, sorry, we were factorizing the top. Okay, so we've got 2 cos x. Here it has to be 1 and 1. And if we want plus 1 in the middle, it would have to be plus 1. It would have to be plus here, and it would have to be minus over there once we had factorized it. Okay, thanks, Aisha, for noticing that. You are absolutely 100% correct. Okay, and then down at the bottom, we have got 1 plus cos x. Okay, so whether it's cos x plus 1 or 1 plus cos x, those are the same. Now that we have factorized, we can cancel that out. And there we go, guys, what we had on the right-hand side. Okay. Okay, does that make sense to everyone? Where would we get our marks? Well, I think we would definitely get a mark for 2 cos squared x minus 1. We would have to get a mark for reducing. I don't know if they would give us a mark at matric level for subtracting 360. A mark for factorizing, and I imagine there was another mark in here as well. Maybe a mark for cancelling correctly. Okay. All right, well done, everybody. Okay, so 6 marks in the beginning, 4 marks there. That wasn't too bad. Now it is sine 36 equals 1 minus p squared. And part of the reason why I was getting you to give these things names is so that when you know what it is that they're asking you, you know how to answer the question. Because so often that's what happens in maths, is that you know how to do the work, but you fail to recognize when a question is asking you a particular thing. So that's why I was trying to get you to identify these things by name. All right, so sine 36 equals 1 minus p squared. Determine without the use of a calculator each of the following in terms of p. All right, so with this question, where is our starting point? Sine 36 is 1 minus p squared. We have to do one of 2 things for this question. Can anybody tell me what they are? Absolutely. Draw a diagram. Or
Ma'am, can it also be identifying the angles on both sides?
when you say identifying the angles on both sides, what do you mean exactly, Cassandra?
Our first angle will be 36, and then our second angle will be 90 minus 36, which is 54.
Fair enough. Okay, absolutely. So, but that would have been after you had drawn the diagram, isn't it? That would be working out what the angles inside the triangle would be. Absolutely. But what I was trying to get at here, and you're not wrong, but what I was trying to get at is that when you answer a question like this, right, you either have to draw a diagram and make sure that you label everything properly. If you do not label the angle as 36 degrees, you will not get any marks for the diagram. Okay, or your alternative, if you don't want to do that, is you've got to show the theorem of Pythagoras. Okay, if you want all the marks in a question like this. Okay, they are particularly strict about that. Okay, so either you have to use the identity, right? So in other words, Pythagoras, or you have to draw a diagram. Okay, when you draw the diagram, as I was saying, you must make sure that you label your angle. So in other words, okay, my horrible set of axes here, X and Y. And there is my terminal arm. Okay, you have to label this as 36 degrees. You don't have to work out what this is, but if you do, then you can use it in your solutions. If you don't, you can't work with it. Okay, so as you were saying, I think it was you, Cassandra, you were going to say 90 minus 36, which is correct. So that would have given you 54. Not necessary, but this one is necessary where you've labeled it as 36. Okay, or your alternative in this case is to use Pythagoras. If they have given us that sine 36 is, so they've told us that sine 36 is root 1 minus p squared. What piece of information have they given us here? What does this mean for us? How are we going to use this? What are they telling us in relation to the diagram? Okay, so we interpret sine 36 as y over r, don't we? Okay, that's what the sine of any angle means. So this matrix is your y. Okay, so they are telling you that for this diagram, y is 1 minus p squared. Exactly, Tanika. All right, and r is equal to 1. Okay, so in other words, yes. So in other words, they have given us, we do not know what the x coordinate is at the end of the terminal arm, but they have given us the y coordinate, and we know that the length of the terminal arm is 1. Okay, so our other alternative here is to use the theorem of Pythagoras. So that would leave us with x squared plus root 1 minus p squared equals 1 squared. Okay, so that means x squared plus, right, so then here we would end up with 1 minus p squared. Sorry, we don't need the bracket. Would be equal to 1 squared. Okay, so that means that x squared would be equal to p squared. And because we are working in quadrant number 1, x is going to be equal to, I don't know why it keeps doing that. It makes me so irritated. Sorry, guys. X would be equal to positive p. I give up. Technology is great when it works. All right, so x would be equal to p in this case. Okay. So those are our two alternatives. Either we're going to draw a diagram, make sure that we label that it's 36, and then we're going to use the theorem of Pythagoras, okay, to work out the value of p. Now that we have done that, we can go ahead and go and answer the question. So let's see if we can quickly get these done before 6 o'clock. All right, so the first thing that they want us to do is work out the tan of 36. Okay, that's not too bad. How would we work out the tan of 36? Oh. Sorry, guys. Sorry, Nicole, I'm in Elisa. I'm having finger trouble here.
No worries, you're back now.
Happens every now and again. I don't know why the board does this. I really don't. As a friend of mine that works with me always says, a classroom full of boys cannot make me cry, but a computer can. So very definitely the truth. Okay, so tan 36, you know what, Kanisila, you can even make life easier for yourself than that, because remember, everything you're working with here is in terms of 36 anyway. So just write tan 36 as y over x in terms of p. Okay, so y would be root 1 minus p squared, and x would be p at the bottom. Exactly, Amanda. Exactly. Okay, this question is out of 3 marks. Okay, so included in those 3 marks would be a mark for the diagram for Pythagoras, and then for working out what the, either a mark for the diagram or for Pythagoras. So either one of those two, a mark on that, and then a mark on your answer. Okay. 5.3.2, this is the difficult question, and here they want us to calculate the cos of 108. So now we have to try and find a relationship between 36 and 108. What do you guys think? Sure, lots of ways that we could do this. Let's try and do it the shortest way we possibly can, though. What's the relationship between 108 and 36? Or
Ma'am?
you can do, yes, go for it, Cassandra.
Ma'am, I'm not sure if this is right, but I think that the starting point will be if we use our reduction formula to reduce our 108.
Absolutely, absolutely. Now, Cassandra, what I really liked, yeah, 36 times 3 is 108. Can you see it? That's quite right. But do you remember in the beginning here, I had said to you that if you labeled this angle, if you label that angle, then you're allowed to use that in your solution. But you can't say, you can't work with 54 degrees if you haven't put it in your diagram over here. So we could work with 54 if we wanted to, because 54 times 2 is 108. Traditionally speaking, though, what this question really wants us to do is this question wants us to use our reduction formulae, like you said, Cassandra. So in other words, what we would notice here, sorry, let me just write in proper pen, is that, and again, when we use our reduction formulae, 180 minus, 180 plus, 360 minus, don't make up other reduction formulae. 270 plus and 270 minus does exist, but it's outside of our CAPS syllabus. So we don't use reduction formulae, we haven't been taught. Okay, so if we use 180 minus, we would end up with negative cos 72. Does that make sense to everybody? So 180 minus 72 would reduce to negative cos 72. Everybody happy with that? And of course, 72 is double 36. So we could write this as negative cos 2 times 36. Everybody happy with that? Okay, so that would give us negative cos, no, it would give us negative, let's use a bracket. And then here we could say 2 cos squared 36 minus 1. Let me not get that wrong. Okay, almost there, guys. Now we can sub in what cos of 36 is. And if you recall, the cos of 36 in this case would be p over 1. Okay, so that would be 2p squared minus 1, and therefore our final answer would be minus 2p squared plus 1. Okay. Okay, but is 108 minus 72, is that a reduction formula, Michelle? Is 108 minus 72 a reduction formula? So this is what we're saying about don't make up other rules, okay? Because 108 minus is not a rule. 180 minus and 180 plus and 360 minus are rules, but 108 minus is not a rule. Okay, I'm glad you made that mistake, because now you get to see what I was saying at the beginning. Oh, so you got lost at the third step, yeah. Okay. I mean, I mean, if only we had more time, hey, we could just sit here all night talking about all the different ways that we could answer this question. Because, I mean, if we went back and we had a look at it, we could also work with a 54. I mean, I've just happened to use 2 cos squared 36 minus 1, but we could actually use any of our cosine double angles. And in fact, you know what, guys, we could even work with compound angles here if we wanted to. Sorry, I know that the TAs must be desperate to go, but if you wanted to, you could even do this, something like 72 plus 36, and then work with that as a double angle, whatever, and okay, you get a slightly different answer, but it would still be correct. So you could do it that way as well. Okay, everybody, I hope you really enjoyed that. We'll carry on with trig on Thursday. Okay, But yeah, thank you for joining us, and I hope you enjoyed the lesson. If you've got any questions that you want to ask, you're welcome. Otherwise, I think we need to do the poll. Is that right?